In this section, we will discuss monitoring performance. We will use the vSphere Web Client to do a performance overview of the ESXi host and a performance view of virtual machines. Let's start out with ESXi host performance overview. If I go to my vSphere Web Client and I select an ESXi host, I can then select the Monitor tab, and under Performance I can see we have an Overview and an Advanced tab. And if I look at the Overview tab, it shows me that CPU utilization for this ESXi host is at about 50 to 60%. If I scroll down, it also shows my memory utilization. It was low for a while and then it spiked. It shows my memory swap rate, which is nothing, which is good. We can see that the disk activity in milliseconds is very low. Disk activity is low. CPU utilization is at about 3/4 utilization. And if we look at memory utilization, we can see it's up and down. It is at from 76% to about 85%. So it's a busy ESXi host, but I would not say that it's maxed out. The disk rate is low, very little disk activity, and there is not much activity on the network either. Now let's look at ESXi host performance advanced tab. So we were looking at the overview tab. Let's look at the advanced tab. The advanced tab allows me to focus in on key variables, and you can see that we are now in the CPU view, and we can see in this example CPU utilization is about 60%, and then it spikes up to 80% for a while, and then it settles back down. And if I select the view drop down, I can look at the data store, and we see not much activity on the data store. And then if I select the drop down and I select memory, we can see we are using about 75% of our memory on this ESXi host. And if I select the drop down again and I select network, I can see network activity is negligible. It's only in the kilobits per second. It's not even hitting the megabits per second. That was ESXi host performance. Now let's look at virtual machine performance, both overview and advanced. If I select my virtual machine here, the one called server 1, you can already see it has a little alarm on it. And if we look at the monitor tab under performance, under overview, we can see that CPU utilization for this virtual machine is maxed out at 100%. We can see that CPU utilization for this virtual machine is totally maxed out. Memory is kind of high, hasn't been much swapping. CPU utilization pretty high. We can see memory utilization went from 25% to 80%. Not a lot of disk activity, and not much activity on the network either. And then if we select the Advanced tab, then we can look specifically at CPU utilization for this virtual machine, and we can see it is maxed out. And then we can look at the data store for this virtual machine, not very busy. We can look at memory for this virtual machine. It's using 50 to 75% of its memory, and very little network activity. So what we've done is we've done the overview and the advanced view for the ESXi host and for a virtual machine. Now let's discuss interpreting the performance statistics, particularly finding the bottleneck. And when we say bottleneck, we mean the thing that's slowing the system down. So if the user says, boy, this network is really slow, it's our job to figure out, is the problem the CPU, or RAM, or the disk, or the network? Is the problem the virtual machine, or is the problem the ESXi host? So let's start out with processor monitoring. If a virtual machine is very slow, we have to ask the question, is the problem the ESXi host, or is the problem the virtual machine? So what we can do is go to the vSphere web client for the ESXi host, and under the Monitoring tab, under Advanced, we select CPU. We select CPU, and we can see that CPU utilization is through the ceiling for this ESXi host. Now the question is, which virtual machine is taking most of the processor utilization? So if we click on Chart Options, and then we select Chart Type, and select the drop down, and we select Stacked Graph per virtual machine, we select all of the virtual machines, and we select percent CPU utilization followed by OK. Then we can see that server 1 is taking up or accounts for about 2/3 of all of the CPU utilization which is being used on this ESXi host. Let's look specifically at the CPU utilization for this virtual machine. If I go to my virtual machine called server 1, under CPU utilization, you can see that server 1 virtual machine is totally maxed out. So what we can do then, if a virtual machine is CPU constrained, we can assign more CPUs to that virtual machine. And you know how to do that. You right click on the virtual machine, select Edit Settings, and then select the drop down and add as many CPUs as you would like to that virtual machine. If a single virtual machine needs more processing power, then you assign additional virtual CPUs. But what if the entire ESXi host is maxed out? And how do you define maxed out? A danger threshold is typically defined in one of two ways. One way of defining a danger threshold is that when utilization is greater than 85%, that's considered a danger threshold. Then you should do something. But another way of phrasing it is when utilization approaches capacity, then that is considered a danger threshold. If we look at our ESXi host in this particular example, we can see that CPU utilization for the entire ESXi host is totally maxed out. So if the entire ESXi host is CPU constrained, then we add CPUs to the ESXi host. And if we have a blade server, the way we add CPUs is to add a blade. And a blade is this thing, it looks like the size of a lunch tray, and it's a circuit board that has 2 microprocessors and 4 gig of RAM. So by adding a blade to the blade server, you are adding CPUs and upgrading the ESXi host. Now let's look at monitoring memory utilization. If we look at this ESXi host, we can see that the memory consumed here seems to be about 75%. But I would like to look more specifically at some of these key variables. If we click on Chart Options, we can see that what's meant by active memory, and active memory is defined as the amount of memory that is actively used as estimated by VM kernel based upon recently touched memory pages. And if we look at the definition for consumed, that's the amount of host physical memory consumed by a virtual machine, host, or cluster. And if we scroll down a little further, we can see that memory granted is the amount of host physical memory that is mapped for a virtual machine or host. And we can see that consumed shows we're using about 3/4 of our memory. Another variable I would like to look at here is what's called ballooning. And if we go to the vSphere VMware publications, we can see that a balloon driver collaborates with the server to reclaim pages that are considered least valuable by the operating system. And we can see that a balloon driver is used to inflate and force a virtual machine out of memory, which makes more memory for other virtual machines. A balloon driver is a piece of software that forces virtual machines to use less memory. It pushes virtual machines out of memory. It frees up memory for other virtual machines, and it only activates when there is insufficient RAM. So, if ballooning activity is high, then that indicates insufficient memory. Well, if we look down here, the ballooning activity, we can see that it's 0. So memory utilization might be at 75%, but it's not like we're at a danger threshold. Ballooning is 0, so we're fine. And then another key variable to look at is the swap used. This is called paging. Paging is when a virtual machine runs out of memory and the extra data can temporarily spill over to the hard disk to what's called a swap file. This is called paging. It only happens if we run out of memory, so we really hope that paging doesn't happen at all. And if we look down here, we can see that there has been 0 activity on the swap file, so that indicates that there is not a problem with the amount of RAM on this entire ESXi host. But if memory utilization were high on the entire ESXi host, how would we identify which virtual machine is taking the most memory? Well, the way that we do that is we go into Chart Options, we click on Chart Options, and under Chart Type we select the drop-down and select Stacked Graph per Virtual Machine. We select the virtual machines that we want to measure, and we select the variable we want to measure, which is consumed memory. We click on OK, and we can see that server 1 is taking up 2/3 of all of the memory which is being used on this ESXi host. Now let's look at the memory for that particular virtual machine. If I go to that virtual machine called server 1, and notice there's a little red error message on it indicating that we're short of memory, we can see that memory utilization is at 32%. So actually that's not really a problem at this precise moment. It just so shows that memory for this virtual machine is only at 32%. But if memory utilization for a virtual machine was totally used up, if a virtual machine was out of memory, and if you had a sufficient free RAM on the ESXi host, then you can add more RAM to the virtual machine. And of course, you know how to do that. You right-click on the virtual machine, select Edit, Settings, and then under Memory, it was 4 gig. I will change that, and I will type in 8 gig, and that assigns 8 gig to that particular virtual machine. That's if one virtual machine is out of memory. But what if the entire ESXi host is out of memory? If we see that the entire ESXi host is short of memory, we can add memory by adding a blade. And as you know, each blade has 4 gig of RAM on it. Now let's look at disk utilization. We can look at disk utilization, and we can also look at latency. There are 2 types of latencies we're supposed to measure. The kernel command latency, which is the average time spent in the VM kernel per iSCSI command. High numbers, meaning greater than 2 to 3 milliseconds, indicate an overworked ESXi host. That's in the kernel on the ESXi host. And another key variable is physical device command latency. That's the average time the physical device takes to complete a SCSI command, and high numbers, meaning 15 to 20 milliseconds, indicate an overworked disk array. So if we go into the drop-down and we select disk, we can now look at overall disk utilization, but that really doesn't tell us that much. If we go into chart options, we can then select these 2 key variables, kernel command latency and physical device command latency. We select those 2 variables and click on OK, and there they are, kernel command and physical device. Kernel command is 4 to 8, and physical device command latency is at 20 to 30. And if you recall, the danger threshold for kernel command latency was 2 to 3, and it's at 4 to 8. And the danger threshold for physical device command latency is 15 to 20 milliseconds, and that's 20 to 30. What this indicates is it's an overworked disk array, and we need a faster disk array. So if we find that the disks are constrained, then we can move the virtual machine files to a different data store, or implement disk striping on the disk array, or get faster hard disks such as SSD. We could implement network interface card teaming on the storage area network, or we could upgrade the storage area network technology from iSCSI to fiber channel. Monitoring network activity. If you go to one specific Windows server, you can see the activity for the network interface card, but only the one network interface card on that Windows server. Now, if you use a program such as Wireshark, that can show you the activity of all of the computers on this segment, and you can see that there is about 50% utilization of network bandwidth. And then another utility you can use is I/O meter, and that allows you to identify if one particular computer is taking a disproportionate amount of resources. So let's look at the monitoring the network activity using the web client. We are on our ESXi host under monitor under performance, and if we look, we can see that the utilization is only in the kilobits per second. It's not even in the megabits or the gigabits per second. So there's not a problem on this network. But if we find that the network bandwidth was heavily constrained, then we should verify that VM tools are installed on all the virtual machines. We can implement bandwidth throttling to prevent one virtual machine from taking network resources from other virtual machines. We could separate our networks into separate VPNs. We could add a second network interface card and implement network interface card teaming on the storage area network, or the production network, or we could upgrade the network technology from 1 gigabit per second to 10 gigabits per second. And I would like to discuss the concept of danger threshold. The danger threshold can be represented as an absolute number or as a deviation from the baseline. Now, we typically think of a danger threshold as an absolute number, and the typical example would be if CPU utilization is greater than 85%, then that's a danger threshold. But there's another way to identify a danger threshold, and that's called deviation from the baseline. A baseline shows average utilization over time. And in this example, we can see that CPU utilization for this system is 20% day after day, week after week, month after month. So suppose I were to tell you that CPU utilization were 60%. You might say, well, 85% is the danger threshold, so there's nothing to worry about. But if we saw that this system had a baseline of 20% for the past 6 months, and then one day the CPU utilization tripled to 60%, well, that's a significant deviation from the baseline, and that indicates some sort of problem that we should investigate. Danger thresholds can be represented as absolute numbers or deviation from the baseline. And this concludes this section.